Hi everyone and welcome to the series of Mathematics Foundations. So we will start today by reviewing some basic algebra and we'll start from the very beginning, like sets of numbers. Okay, so these topics are just important in handling mathematics that will come later throughout the channel. So devote whatever time is necessary in this series of the topics that you need to review. So even if you haven't studied mathematics for ages, don't worry, you all have a space in this channel. So start with whatever one that you want to review. So I will start from the very beginning and then we will upgrade our mathematics along the way. So if you haven't studied mathematics forever ago, or if you are new to mathematics and you want to just dive in and go with us in this journey, you could just start from this series. So we'll talk about numbers, like how we know numbers from the when we were kids. So I'll talk about sets of numbers. So starting from the natural numbers, like naturally how we count. So the set of natural numbers, or we call it positive integers. We denote it by capital N, but with a little bit like that, capital N. And it's a set of numbers that we know it as kids, like when we start to count 1, 2, 3, 4, 5, 6, up until infinity. And actually sets, like when I say set, maybe I should have said that in the beginning. When I say set, the collection of objects, sets usually is a collection of objects. Okay. Collection of objects. So each element is called, each object is called element. Okay, so just to start with everything that is not, and we don't want any ambiguity, so we want to make everything clear. And we could define sets by putting the object in between inside braces, like this ones. The curl parentheses maybe appropriately could be written like that. Not very good at drawing maybe, but anyway, this is how we put the set. So in these curl parentheses, or we call them braces, 1, 2, 3, and let me just return to this color. And also we could talk about negative integer. That's why I specify positive integers. Negative integers is a set of, just let's put it like that, not give it a specific value letter. So the same as the natural number, but with minus sign. So each number in the negative one are the negative integers. Okay, and the set of integers in general, we call it Z. So it's a fixed notation for these integers. Are the integers like starting from all the negative, so we order them from the smallest to the largest, and 0, and then the positive integers. So this whole set is called integers. Okay, and now with the most familiar one that we deal in our life is the set of real numbers. Okay, the set of real numbers is consisting of two sets. We call them rational numbers, and we'll see in a minute what they are, and irrational numbers. Okay, so actually rational numbers rational numbers we denote it by q. We do like that just to differentiate. So natural numbers are the numbers that could be in the form a over b, okay, where b not equal 0, because in mathematics we don't divide by 0, okay. So examples, we know them very well, these rational numbers, like half, for example, 5 over 3, it could be with minus. Also, if we say 50%, talking percentage, we will study percentage also, maybe in next lessons. Percentage, which when we say 50%, I mean 50 over 100. So at the end, it's something 1 over half, 1 over 2, so half. It's something that I could put it in a over b, okay? So these are all rational numbers. Also, every integer, so the set of rational numbers also contains the integer, because every integer, for example, 2 is in the set of integers, right? I could write every integer as 2 over 1. So everything could be 2 over 1, because 2 over 1 is 2. So every integer, whatever it was, a, could be written a over 1. So it also contains a set of integers with positive or negative, okay? So also I could write this a over b things, 2 over 3, for example, I could write in decimal form. So it could be like that. Also, this half could be 0.5. All right. And yeah. So the other set is the irrational numbers. Sorry, maybe I misspelling that. That's double R. Yeah. The set of irrational numbers. Okay. So it says that we cannot have the element that we cannot be written as a over b. Okay, we cannot write it in this form. For example, the famous irrational numbers that are really very important numbers, by the way, they are not bad numbers, these irrational numbers. So the famous irrational numbers are the constant pi, the famous pi, and e, also the exponent. We will learn about all these. And also root 2, for example, because we could get root 4, which is equal to, if it is a perfect square, but when it's not a perfect square like this one, root 2 is a irrational number. So we could sum up all these examples in the set of the real line. So we learn in school the real line. So if you have the origin at 0, then we have the integers, negative and positive ones, and we could have like half here, one of the rational, root 2 is falling here, pi there, 3 over 3 point something, and we have minus, for example, minus 1.5 or minus 3 over 2. We could write it this way. Just make it clear. Minus 3 over 2 and minus pi there. So just to give some examples in the real line. Okay, so far so good. So let's continue. We could continue with some properties of these numbers. Properties of real numbers. And I don't know if I said, but the real number set we denoted by R, but with this, like this one. Yeah, capital R. So the first property that we could say is that the real numbers are transitive. Transitive, meaning what? Transitive of equality, sorry, of equality of real numbers. Meaning what? If A equals B and B equals C, that means also A equals C. So we're just really reviewing all the things that we have ever known about numbers. So I'm telling you, if you haven't studied mathematics for ages, you have a space here. So we are starting really from the very beginning, and we'll go step by step until we build a strong foundation in mathematics, and then we could handle even further topics and further series and maybe advanced mathematics contents. Okay, so for example, if I have like it could like a, b, or x and y. So if I have x equal y and y was equal, and we turn out that y equals 7, then also x is equal 7, because the equality is transitive in the real numbers. Okay, also another one that also you are familiar with, I'm sure, but let's say it, the commutative of addition and multiplication. So if we have a plus b is the same as b plus a. For example, like a have 3 plus 4 is equal to 7, right? The same as 4 plus 3, so it's commutative. Also, AB equal BA. So if I have 3 times 7 is equal, I know it's equal to 21. It's the same as I say 7 times 3, which is again 21. So just telling you that, okay, addition and multiplication are commutative in the set of real numbers. Also similarly, and I want you to go further and just have examples, just play around with numbers, that they are also associative addition and multiplication. So if I have a plus b plus c is equal as if we first add a to b and then later add c. So we know that by heart. Also a multiply bc is as the same as multiply a and b first and then multiply c. So please check that these are the things that are just coming intuitively for you. Okay, also the identity, both addition and multiplication has identity. So in the addition we have 0, like a plus, let's talk about the addition, a plus 0 equal a, because in any number, let's say 3 plus 0 would give me 3. And the identity means the element that does not change the value of the number, despite either it was addition or multiplication. So for multiplication, what is the number that I will multiply a with and give me a? So we know it's 1. So for example, if I have like a minus 4, it could be negative number, positive number, rational, irrational, any real number, multiply 1 will give me the same number. Okay. All right. Also, the set of real numbers have the property of they have an inverse. Okay. So for the addition, the inverse for the addition is the element that I will add to a, and it will give me the identity. It will give me 0. So we know that, what is it? Minus a. So the inverse of a in the addition is minus a. So for example, if I add 3 to minus 3, 3 minus 3 is 0. Okay. Similarly, for multiplication, so what is the number that I multiply a with and give me 1, the identity. So what is the number that we multiply is 1 over a. So it's the inverse of the multiplication inverse of a. So we agree that a is equal any integer. We could put it a over 1. So to get the a inverse, and you could denote it by just a to the minus 1. And so the numerator, we put it in the denominator, and so we reverse it, flip it. We could say flip it. So the numerator will become 1 and the denominator will become a. So this is a inverse. And for example, if we have 3, we multiply by what to give us 1, as what we used to have when we were kids. So it will be 1 over 3. And even if this a was, for example, 2 over 3, then a inverse would be flipping this rational number. It will be 3 over 2. Okay? So this is the inverse of the addition and multiplication. Okay, let's continue. We have another last one that we talk about is the distribution or distributive property. Okay, so the addition, where the addition and multiplication comes together. So if we have a multiply b plus c, we will distribute it as a multiply b first, distribute here, then plus a multiply c. We leave the operation in the middle as it is, so it will be, so even if it was minus, okay, a plus or minus, it would be ac. And also, even if it was from the right or from the left, it will be BA, because we understood that even if it was minus also, we understood that addition is commutative, and multiplication is commutative as well. So also if we multiply, okay, these are the basic properties. So we could get further properties, like if we multiply 0 by a, it will give me 0, as if we multiply also a by 0. So from the left or the right, if you multiply any number with 0, it will give me 0. So we are just really just refreshing all the properties that we know about numbers. So this is just a refreshment class to start doing some mathematics, okay? So also extended sum, like, okay, if we define the subtraction, here I already said plus or minus, but let's define the subtraction using the plus, the addition. So it is a plus the inverse, like when we say the minus of an element or a number, it's the addition inverse, which is the negative of a number. So the addition inverse, for example, like if we have the number 3, the minus 3 is minus 3 intuitively. But if minus 3 minus minus will be plus. So the inverse of minus 3 is 3. The inverse of 3 is minus 3, and so on. Okay. Also, we could define using these inverses, like the inverse for the addition gave us the subtraction. Also, the inverse of multiplication, we could define the division. Okay. So the division here was subtraction. Okay. It's just the multiplication of a by b inverse, and we agree that b inverse, we just flip the b over b, and then it will be a over b. Okay, and b not equal 0, we don't divide by 0. So I will stop here for today, and in next lessons we will see how we could manipulate these fractions so we will be more comfortable when dealing with fractions, how we add them, how we multiply them, and how we divide them. So I will leave you here today, and next time we will talk further about fractions and powers and roots, and we'll go ahead to building a strong foundation in mathematics. So bye bye and see you next videos.